Hey guys, welcome to a new video. In this video here, we're going to take a look at how we can set up a whole computer vision training pipeline with YOLOv9. So basically going to start from scratch. We're going to take some raw images in our dataset. We're going to use RoboFlow with the new annotation tool, so you can also label your images. Just throw your images in there, prompt it what do you actually want to detect, what are the different classes that we want to have in our dataset, and then how we can export our dataset, throw it into Google Collab notebook, train our own custom YOLOv9 model, export and use it in our own applications and projects. So we're going to cover the whole computer vision pipeline step by step. And if you watch this through, you'll be able to set up projects on your own and also train your own custom models on whatever dataset that you can find out there. So we now jumped into RoboFlow. This is the tool that we're going to use to auto annotate our images. We just created a new project here. I'm just going to call it car 2, and then we also have some annotation groups. Then we have all these different kind of like project types that we can choose from: object detection, classification, instant segmentation, key point detection, and so on. First of all, here, just want to show you guys the images that we're going to use. So let's go inside my desktop. Then we have the images in here, and then I just have a bunch of images, 98 images in total. And here we can just see some image samples. So this is just like a highway or a freeway where we have like a camera. This could be like a CCTV camera that you want to do traffic analysis on top of. We can even apply object tracking on top of it. I'm going to show you all of that. So the whole pipeline and how we can run inference at the end. So it's basically just a camera, live camera, where we have sampled some images from. You can also use your own web camera. You can use like different types of cameras, video streams and so on, even just individual images where you actually want to generate your own data set so you can train custom computer vision and AI models. So here you can basically just see all these cards here. We can prompt auto annotation tool with RoboFlow using grounding dyno. So that is a foundation model that you can actually like prompt. So it's going to find a specific class, but also give you the bounding box around each of the individual objects. So yeah, we can both like just specify a car. We can also like have trucks and so on. We can add an arbitrary class. So it's not just take all of our images here in our dataset that we want to use, create a public dataset. So first of all, here we just create the dataset. Now we're inside the RoboFlow project tool. To start with, we just need to drag and drop all the images in. I'm just going to hit Control A. So I copy all the images and I'm just going to drag them in. It will just take a couple of minutes, probably just a couple of seconds, depending on your internet connection. So right now we have all our images. We can now hit save and continue. It's going to upload the files, but we can just get like a quick overview all over all the images. Once it's uploaded, now we can go in, start the manual labeling process, but that is very time consuming. And I promise you guys, it is also very boring, where now we can actually just automate it with some of the new foundation models that have come out. And this both applies for object detection, but also instant segmentation. So we have different models, different foundation models that can both output like bounding boxes, segmentation mask, and so on, and even assign a label to them. So we can use that to get our specific objects in our data set. So right now we can just hit start auto label, and this is everything that we have to do. Now we get these different options. So we have different classes. So first of all, we need to specify our class name. So that is a car, and we can also prompt it. So we're just going to prompt the car as well. Could be that we want to like prompt it with specific shapes or even like colors. Let's say that we only want to detect yellow cars. We're also able to do that. We can also go in and add multiple classes here. Let's say that we want to add a truck as well. If you want to do that in our dataset, truck, we could even just be like a white truck. So we only want to detect those in the images. And this is actually just how you keep on adding classes for the specific objects that you want to train your model on. So you can then use it later on to do detections in your own custom applications and projects. But just delete this class here. Let's just go in and act like just detect the cars. First of all, we get a couple of test images. So we have 4 in this example, and then we can just generate the test results before we process our whole data set. So we actually need to have some credits here on the RoboFlow platform to be able to use this tool. So that's also why it's pretty nice to just see this preview before we actually just run through all our images. We also need to play around with the confidence threshold here as well, which basically just means like how confident is the model in each of the predictions for the classes here that it has assigned, and also the bounding box. And then you can basically just fine tune it. Let's say that the model is 50% confident, then it's actually going to assign the label car and also draw the bounding box. And then we can just have this track bar that we can play around with. Here we can, for example, see that our model is not confident more than 85% in any cases, and then we can just lower it to get more predictions. So we can see that we have some cars here up at the top. The model is not able to detect it now, but if we just scroll a bit further down, we can actually like see that it gets significantly more detections. But if we just go all the way to the end, we can see that we get some false predictions over here. These are definitely not cars. So I think if we basically just fill it out around here, so like around 20%, that pretty much just gets every single car in this image, even some of them up here at the top, which is even hard to see from the human eye. So right now I actually think that this confidence score threshold is pretty good. We don't have to do anything. We can just scroll through a bunch of the examples here in our test set. Just scroll up. So here we just scroll through them, and I'm pretty satisfied with the results. Just run through 4 examples. We can see here that we detect a car, even though it's just like a trailer behind the car. But we can train our model on it. We can go in and clean it up. We also have to go into the approval stage after this step. So auto label with this model here. Now we can see that it takes 1 credit per image. Start the auto labeling. It'll just take a couple of minutes, maybe just a few minutes. And then we have all the labels for dataset. We can now export it and use it to train our own custom models. So we can now see that it's done with the auto labeling job. We can now go into it and we can just like add approve to dataset, or we can go in and manually approve them or reject them. We can even go in and adjust the bounding boxes if you need to do that, or if it had misdom detections, you can go in and add those or delete detections if we have some that we don't want. So you can basically just go manually through it here again, just to make sure that you have all the correct labels before we train our models, because trash in is also trash out when we're talking about like training AI models, and that pretty much applies to every single domain within AI. But again, generally these images here look pretty good. Again, it shouldn't have too many problems with cars, but if we're just satisfied with it, we can also just go over this preview, just scroll through them, see, okay, it looks pretty fine. We can just add approve to dataset or approve all up here. There we go. Now we can choose the train, validation, and test split. Let's just go with default values here. Maybe just lower the validation and test a bit, and we hit add images. And now it's going to add that to our data set. We can go into the left tab here, hit generate. Now we can go in and add pre-processing steps and also augmentation if we want to like have even more data and make our model generalize better. Could, for example, if we just go down here, we can have augmentation. So we can have both flip the image, we can rotate it, crop it, rotation, and so on. When we're just detecting cars in this specific example, it probably might not make sense to do flipping, not even rotation. Could be a bit of cropping, but again, it depends on the camera angle. Right now, it's just going to do a bit of cropping. So there we go. Now you can see that we can increase the cropping. So this is the zooming effect in the image. So let's just add around like 10% for that, basically just to get more data to our data set. Now we're going to choose like how much we want to do for our annotation. Maybe just go ahead and use augmentation or delete that. So we have crop 10%, and let's just go in and add some saturation. There we go. We'll hit apply, continue, and now we can create a new dataset with 176 images. So again, here we can see that we act like just double our dataset by using data augmentation. So if you don't have enough data, you can basically just go in and use data augmentation. Now we can train a custom model here. We can also export dataset. We can train it directly with RoboFlow. We have our dataset split, pre-processing, and augmentation steps. So now going to export the dataset. We're going to train a YOLOv9 model. So they have all the different formats here, but again, we're going to use Ultralytics to train our YOLOv9 model. So we could probably get away with using the YOLOv9 format. I'm not too sure about what the differences are, but they're probably very similar since YOLOv9 is built on top of the Ultralytics and YOLOv8 and 5 framework as well. So it's basically just the text annotation files where we have the class ID and also the bounding box value. So that's pretty much it. We just have an image and then we have a file with all the individual classes, all the individual annotations with the class, the bounding box in a single file, and those act like just like image and label pairs. So now hit show downloadable code, we'll get a code snippet. Then we can basically just copy this code snippet, throw it into our Google Colab notebook and train our models directly. So right now I just created a Google Colab notebook from scratch. I'm going to show you all the individual steps that I'm doing instead of just like having a Google Colab notebook that we just run through block by block, so you guys can better understand like what's going on in the whole process, and everything will be down in the description so you can just directly take it. Now you're going to learn it from this video and you can try to apply it on your own data sets. So first of all here, we just need to do our imports and so on, but let's now go in and just use Ultralytics. So first of all here, let's go inside the Ultralytics documentation. If you go inside the modes, we can see that we have train, validation, predict, export, and all those different things. We have a bunch of tutorials in here and also with videos. If we scroll a bit further down, we can then see how we can go in and train these models. So there we go. This is actually like how easy it is to use. We just need to import YOLO from Ultralytics, create an instance of our model, and then we can just directly train it where we need to specify the data path. Specify number of epochs, image sizes, if we want to use GPU, and so on. So I'm just going to copy paste this code snippet. First of all, there we go. Inside of our Google Colab notebook, we need to make sure that we have pip install Ultralytics. So this is how you can do it in a Google Colab notebook. We want to run this on a GPU, so we go inside the runtime and make sure that we have our T4 GPU assigned to us. So let's hit save. So connect to the runtime. Now we can see that it has been connected and we're now running this runtime on GPU. Let's go in and pip install Ultralytics, and then after that we should be able to go in and train our model. I'm just going to take the code here as well. So the code, we copy paste in our code snippet from RoboFlow, and we will be able to use our dataset. So the only thing that I've done is just pasting in this code snippet that we got from RoboFlow, and right now I've just deleted my API key and already ran this block of code, so we should be able to go over to the left and see our dataset. So now we have our car, we have test, train, and validation, and we also have our data.yaml file. So if we just open that up, we can actually just see the path to our test, train, and validation split. We also get some other information here, the number of classes and the class names, which is a car. So first of all here, what I like to do just to make 100% sure is that we just go in and specify the correct path. So let's just go in and copy the path directly for our test set, because right now we're using a Google Colab notebook and we have this content directory. And here we have train. And the last one here is validation. There we go. We hit Control S for save. Now we can just close it over here to the left. We can see how we have our images. So these are the images that are showed during the start. And we also have the corresponding labels. We have the class here on the left side, and then we have the bounding box for the rest here. So this is basically just the format that we're using. So now once we have our dataset, I've just scrolled a bit further down, and now we're ready to use the Ultralytics code for training our model. The only thing that we need to do is specify the path here to our data YAML file. So we're just going to copy that. There we go. We set our data equal to our data YAML file. We specify the number of epochs. We can probably lower this to 30 just for the sake of training. The image size. So this is the image size that we export our dataset to with RoboFlow. It's also automatically going to use the CUDA device, but this example is if you have multiple devices and CUDA devices available. So this is pretty much everything that we need to specify. Of course, we can specify a lot of other different kind of like arguments, but you can find those on the Ultralytics documentation. If you just go inside train, we can specify all of these arguments. So the number of epochs, patience. If we want to tune around on the batch size, we probably want to lower that as well, depending on how much RAM you have. You can specify save, cache, the device, and so on. If you want to use CPU or GPU, you can go in and check all of the arguments in here, and they also have a pretty good description of it. But let's just go in and specify the batch size as well. So batch equal to 8. There we go, we should be good to go, and within the GPU limits. So we create an instance of our model. Let's just do that in one block of code. So actually I just saw here that we're using YOLOv9 model, but if we just go inside Ultralytics, we can go inside our models, and these are all the different models. You can go in and see if they're supported for training, inference, exporting, and so on. But right now let's go down to YOLOv9, and we also have all the other models over here to the left. Let's scroll a bit further down. We can see we have YOLOv9, C, and also E model usage. This is how you can use it, and again you just need to specify YOLOv9 C. So that's everything that we need to change here, YOLOv9 C, and this is how easy it is to swap between the different models with Ultralytics. So now we're going to create an instance of it. Let's see if it's able to do it. First time we run it, it's going to automatically download the pre-trained weights. So we're actually going to do fine tuning. So first of all, the models here have actually been trained from scratch on the CharuCo Dataset. So that is a pre-trained model, and now we're going to fine tune it, which means that we're just going to make some small modifications, some small changes to the weights in our neural network and in our model. So it fine tunes to our specific data instead of like a general dataset as the CharuCo dataset. So there we go. Now we have it. We can go down and use the training code. So let's just delete this part. It has nothing to do with what we're running. And again, you guys can see how easy it is to set up this whole pipeline. Let's now try to run this and see if we can get some results and act like the training running. So now we can see that our model has started training. Only one line of code, and we can train a custom YOLOv9 model. First of all, here's going to download the dataset, download the weights, and so on. We get a summary of the model. So these are all the individual layers in our model. We can also see here that it starts up a bunch of other things. So like both the training, it scans for the training images, optimizer, the validation set, and so on. You can see the optimizer. So it's Atom V, and we also have the learning rate and so on, the momentum. You can specify all of those arguments. But if you go with the default ones, you're pretty much good to go in 90% of the cases. So here we can see all the epochs. We're training it for 30 epochs. We basically just go like one by one. So over here to the right, we can see the mean error position of 0.50 and also the mean error position 0.50 to 0.95 in intervals of 0.05. So it's basically just the precision at different levels, and then we take the mean across all the classes. But in this case here, we only have one class, and we can see that we actually get pretty good accuracy. So we already get pretty good results out of the box because, again, we're just fine-tuning it on a car, and the CharuCo dataset already contains a tons of cars, so it has already been trained on that. Right now we can see we're pretty much done. Let's just let it run here for the last couple of epochs. We also get the class loss, so we can see that slightly decreasing over the number of epochs, the box losses and so on, like how does the bounding box act like fit around your object, and we can also see how many instances do we have per epoch. So an epoch is basically just running through all of our images in our data set and then for every single batch. So when we have a batch size of 8, we just take 8 images from our data set and then we have a number of batches. So our whole data set is basically just divided into batches, and within each batches we will have 8 images. Then we run through all of our batches, our whole data set. After every epoch, we're going to optimize and fine tune the weights in our model, and then we just keep repeating that for a number of epochs and iterations. So now we're pretty much good to go. After the model is done training, it's going to do some validation, and we also get a bunch of different graphs and outputs over to the left in our folder. So we're going to have this run folder, detect, train, weights, and then we can go and extract the best weights and also the last weights. So most often you'll just use the best weights while you're training your model. You just go in directly, hit download, you can download into your own computer using your own custom applications and projects. So we're going to do that right now, and then I'm going to show you how you can load it in and use it on your own. So while it's doing that, let's go in and take a look at the confusion matrix. So that's also pretty useful when you want to detect objects. So ideally, if you have multiple different objects, you want to have all the values in the diagonal. So this is really useful. Just taking a look at the mean error position, the confusion matrix, and also the precision recall. It's pretty much what I'm using most of the time to get a good understanding of how does my model perform. And we can also go in and take a look at how our model perform. So if we go inside our validation prediction, so this is batch 0 in our validation, and we should be able to get the predictions with our bounding boxes. So these images here, the model has not seen these images doing training, but again, like all of these examples, scenarios are pretty similar to each other, and also because this model has been trained on a CharuCo dataset, so it would be able to detect the cars even though we didn't do any fine tuning. But this is just to show you guys how you set up the whole computer vision pipeline, fine tune it on your own data set. So these are predictions directly from the model. So it both gives the label, so car in this example gets the confidence score and also all the bounding boxes for the predictions. So this is pretty cool. We can also go in and take a look at another batch here. So we both had it for train and also validation. So this looks pretty good. Now we actually just validated our model. We're taking a look at the results. We can export it and use it in our own custom applications and projects. But even though I'm talking a lot, guys, this is how easy it is to train a custom YOLOv9 model. You don't have to do anything. The Google Collab notebook will be down in the description, but it's just a few lines of code, and you can pretty much copy paste everything. Copy one thing from RoboFlow, copy one thing from Ultralytics. You hit start train, and you have a custom model. So our model has now downloaded. I've jumped into our custom Python script, and now I'm going to show you how easy it is to use a custom model as well with Ultralytics. Of course, you can set everything up on your own. You can export and extract the results. I also have videos about that, how you can extract the results and use them in your own applications and projects when we have our results generator in here and do inference with the Ultralytics functions. So right now, first of all, here we have from Ultralytics import YOLO. So this is the exact same way that we're creating an instance of our class when we did it in our Google Collab notebook. But now we actually just need to specify another path to our model. So we download our best.pt. So we can just specify that, best.pt. We can also change the name to our car model or whatever name that we want. We just want to have this .pt model. So this is how we can create an instance of our model. And right now we just need to go down and call model.predict. And we can then go in and specify the source, image size, confidence score if you want to save it, and also show we set that equal to true. You can go and see all the different arguments that you can set to this predict function. If you're using video and so on, you can also just change it to track, and it's going to track objects over time and assign an ID to them instead of just doing detections on each individual image. So right now, instead of specifying source 0, that will be your webcam. It's not going to work with that. So right now we can just go in and specify. I have an image example that I just took from the dataset. So right now let's just go in and rename it. So I just have an error here. There we go. Image example. im_example.jpg. There we go. This is everything that we need. We can even set it equal to result. And then we're going to extract all the individual results, bounding boxes, confidence scores, classes, and so on from this results variable. Right now, let's go down to our terminal, hit Python, custom model. Let's make sure that we have saved it. Custom model.py. Let's hit enter and let's see if we get some results. So it's both going to show us the results and also save it. So right now it basically just went out immediately, even though we have show equal to true. But let's go over inside our runs. We have our detect, predict to, image example, and here we can see all the predictions on our image. We get all the bounding boxes, we get everything. So I hope you have learned a ton this video here, guys. It's basically the whole computer vision pipeline. We have tons of different tools that is going to help you set up everything. We don't even need to write any code. We can just copy paste a couple of things, have our data set, also label it, also annotate it with all the new cool AI model that has come out. So this is the whole computer vision pipeline. Definitely test it out on your own data set. You will learn a ton from it. But even though you're using this, make sure that you actually understand how a training loop works, how a neural network works, how they're actually being trained and so on. So we're just not using this as a black box, but we actually know what is going on under the hood, and also have tons of videos about that here on the channel. So thank you guys for watching this video here. I hope to see you in one of the upcoming ones. Until then, happy training.